Okay, this is the capacitor bank panel, alright. So it's a 525 volt capacitor bank. Currently, this is the current power factor is 0.98. Okay, how we going to check whether each step, that means each capacitor bank inside is working in proper condition or not. Okay, first of all, generally we check is there any loose termination. If there's any loose termination, definitely we can see the cable is burned, because all this PVC sleeve, okay, all this PVC sleeve, if anything goes above 60 degrees Celsius, it will cause excessive overheating to this PVC sleeve, then you can see discoloration, or it will fade the color and char the color, become more black color, or it will become hardened. Okay, this is visually see. And then let's check, is there any tripping occur? All this MCCB, is there any trip? If there's no trip, okay, you can see behind here. You can check whether there's any burn cable or any of the capacitor bank visually behind, which you can see the head already bugged out. If it's already bugged out the head, that means the overpressure tear fuse has been operated. Okay, this is the capacitor bank. If let's say this head already bugged out, you can see this thing will go up, and then this will leave up a higher gap. That means internally the overpressure tear-off fuse has been operated. Okay, from here you can see everything is in good condition. So we close back, and then we will check something different now. Okay. Now I'm going to put this thing into manual mode. So I scroll down to switching program. Press this once. As this one blink, I press down. This is NA, that means no, manual mode. Then I press program. Okay. From auto goes to manual. Okay. Then I press up, it will on all the steps manually. Okay, this way, after I on all the steps, I can know the contactor is working properly fine. Alright? Okay, so now as I know all the contactor is working properly fine, I need to confirm is the capacitor bank is in good condition or not. So I just use a clamp meter, AC clamp meter. Okay, then I check all the steps. Record all the findings of the value, current value. Then you will know if let's say the amp is lower than usual. That means the capacitor bank step has been faulty. Alright? You can do the comparison. If you acquire the data every time you check the capacitor bank. 47, okay. Okay, 48. Okay, all the capacitor bank is working in good condition. The current value is okay. And now we're going to put it back to auto mode. Okay, go to the switching program. If you over scroll it, you just press it back to the switching program. Press this one once. Okay. Press up, auto, press program. It will swap from manual, go to auto. Then now it's auto mode. Auto mode, it will automatically cut off all the steps which is overcompensated according to the power factor value. Okay, now it's cutting off all the steps which is not required because under auto mode. Automatically. Okay, do make sure if you manually on all the capacitor bank, just don't leave it, otherwise it will cause excessive over voltages and thus your capacitor bank will damage over the time. This test only can give you for 5 to 10 minutes. I recommend it. Alright, there's another setting is your cos theta, your set point for the power factor. This one I recommend to set at 0.95 and above. Okay, and then we have the CK value. This one you can go for ATC. Sensitivity you can leave it by default. Reconnection time you can leave it by default also. Rated step, this one is a bit tricky. You can use ATC for auto detection, or you can check whether some of the step not being used, and then you can put it to 0 so that the regulator know that that step are not being used. Okay, this is one of the most direct way. Alright, here we have another panel of capacitor bank. So, just then we use the manual mode to check the current of each step. Now we use a different method by measuring the microfarad of the capacitor bank. Okay, currently at this capacitor bank panel, we have 3 steps energized. Step number 6, 7 and 8. Okay, this is a different method to check the capacitor bank. If you want to use this method, first of all, you must shut down the capacitor bank panel first. Okay, now it's energized and it's live, so you cannot check this way. For safety purpose, okay, you must off the capacitor bank panel first. Okay, this is the MCCB going to the capacitor bank panel. So now we off it first. Okay, after you off the capacitor bank panel, power supply, main incoming power supply, the whole control here, no power supply, incoming no power supply, but some of the step just then energized still store some voltage. So it is recommended to allow 3 to 5 minutes for the capacitor bank to self-discharge. How the capacitor bank self-discharge, okay, is actually all the capacitor bank have a self-discharge resistor installed at the capacitor bank. Okay, if you look closely at the capacitor bank panel, okay, this is the capacitor bank panel. Over here, this is the termination for the 415 power supply source. Over here, this is the self-discharge for the capacitor bank. Once you switch off the power over here, there's no power. The capacitor bank will self-discharge by itself using this discharge resistor installed at each capacitor bank. Each capacitor bank will have a self-discharge resistor built in at the termination here. Even this one got, this one got, this one got. Okay, you just have to give it time 3 to 5 minutes to allow it to self-discharge. Otherwise, when you want to measure the capacitor bank for its microfarad, there will be voltage exist inside the capacitor bank, which sometimes can damage your meter or can cause a spark. So allow 3 to 5 minutes for it to self-discharge. Okay, as if let's say you want to straight away measure the capacitor bank, you can use your own way to discharge it by using a cable to jump at the terminal, not face to earth but face to face. Jump it to short it to discharge the capacitor bank, then only you measure. Otherwise, the voltage stored inside could damage your meter. If let's say your meter don't have a self-discharge mechanism. Okay, right now I'm going to measure the microfarad. Okay, this meter I have a microfarad function. Okay, as I select to the microfarad function, okay, let's say I'm going to measure step number 2. Okay, I just put in my probe. Okay, and allow the measurement to take place. Okay, 159 microfarad. Okay, this one. Oh, this one is faulty. The microfarad are so low. So step number 2 is faulty. Okay, let's take step number 1. .35. Step number 1 also faulty. Okay, step number 4. .156. Okay, step number 4. Okay, in good condition. Step number 5. 226. You can use this way to check the rest of the step and record down the microfarad reading. The lower the microfarad, that means the capacitor bank is not in good condition. Then you can consider replace the capacitor bank. So this is another method to check and verify the capacitor bank. However, you cannot verify whether the capacitor bank has short or not short because you didn't energize it. First thing, you didn't energize the contactor. Second thing, you didn't check the value of the microfarad as the 415 voltage reaches the capacitor bank. This way of checking is not so complete, and it also doesn't guarantee the capacitor bank overall is in good condition. This is a second method. But this method is much more safety because you switch off the whole panel, then only you check the microfarad. The first method, we on all the capacitor bank by manually switching on all the capacitor bank step and measuring the current is much more accurate because you can check the contactor to energize as well as the 415 volt go through the MCCB, go through the contactor and go to the capacitor bank as you measure the current here. That can clarify the voltage go inside the capacitor bank and produces such a amp, such current. So the checking of the capacitor bank is actually more accurate if manually on all the steps and measuring the current. As well as you can guarantee that the capacitor bank step is not shorted and there's no tripping. Okay, so after we check all the capacitor bank step, so now we just want to normalize it back. We just switch on back the main switch. And then everything will back to normal. The capacitor bank will automatically switch on the step by itself. Okay. Alright, here there's one more thing I need to share. Okay. If let's say you want your capacitor bank to be much more sensitive, okay, you can go down over here, adjust this one to unity power factor, which is 1.00, or the CK value here, you can use program and use 0.03, or another method is go to the sensitivity, adjust to 20 or the lowest figure you can get. Reconnection time is all about reconnection of the capacitor bank after previously it's been energized. Okay, this is the time delay.